I'm Vignesh and welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone are doing good. So in previous video, I have given a small introduction on different compute options available in Google Cloud Platform. So in this video, we will be deep diving into those compute options when what is the like what is the characteristics of the compute option, when to use those compute options, and we will be seeing some ideal use cases for those compute options. So basically I have divided this video into two part. In the first part I'll be explaining compute options like Google compute engine, Kubernetes engine and app engine. In the next part I'll be explaining cloud run followed by cloud functions. So in previous video I have not spoken much about cloud run, but in this series we will be talking more about cloud run, what is the use, what is the benefit, or what is the characteristics of cloud run, when to use it, all those things in detail. So I made the objective of this videos very clear, I hope so. And without any further delay, let's get started. So first of all, these are the different compute options available in Google Cloud Platform. One, compute engine, it acts as an infrastructure as a service, whereas Google Kubernetes engine, it acts as an hybrid model. Like basically, it is an containerized platform, and it works on multi-cloud hybrid platforms, even in the same cloud platform as well, in Google Cloud Platform as well. When I say hybrid, it involves both cloud as well as on premises as well. So in on premises, if your system or if your application is using Kubernetes, then the perfect or ideal choice would be Google Kubernetes engine, followed by app engine. So in app engine, it acts as a platform as a service in Google Cloud Platform. So it is basically an regional resources, and followed by cloud run and cloud functions. So this thing I'll talk more about in the next video. So for this video, we will be focusing on more on compute engine, Kubernetes engine, and followed by app engine. So compute engine, as everyone know, it is a virtual machine that runs on Google Cloud Platform. It is a zonal resource, and compute engine is nothing but virtual machine. So you can select a predefined virtual machine configuration. So most of the things control you will have it on your hand. You have to configure it, like you have to select the memory, memory, system configuration, storage, all those things. So, and you can also create customized configuration to precisely match your performance and cost requirements. So virtual machines need block storage. So basically when you create virtual machines, we need a storage. So that storage is available in two forms. One is persistent disk, the other one is local SSDs. So persistent disk, it offers storage that scale up to 64 terabytes, and you can easily take snapshots on those for a backup and act as an mobility as well. The other one is you can also choose local SSDs, which enable very high input operations per second. So these are the two basic storage options available, and you can take backup snapshots, create images out of it. You can move it, and you can create another virtual machine from that backup. So all those things it is possible, and there is other concepts in compute engine called managed instance group, unmanaged instance group. So even it compute engine offers global workload balancer as well, so that supports auto scaling. So by this you can place your compute engine workload behind global load balancers. So we can place our compute engine also in global load balancers that supports our auto scaling as well. So compute engine offers a feature called managed instance group. So there is a feature for managed instance group as well as unmanaged instance group. So with this we can, with the managed instance group, you can deploy, or you can deploy multiple similar virtual machines as well. Like for example, if I configure a machine of particular type, I using this managed instance group concept, I can duplicate it according to my requirement, all those things. And there are other concepts like persistence machine as well, non-permittable machines. So for a huge batch processing or batch workload, in this case you can use non-permittable virtual machines, which is used for processing those batch loads, and it is a temporary machine, like it will be on for 24 hours, and it comes with huge discount from Google Cloud Platform as well. So these are the some key features of compute engine, and we will be talking more about those things. What is managed instance group, how to create unmanaged instance group, how to include non-promotable virtual machines as part of that instance group, managed instance group, and how to create backup from the disk or from to an image to a snapshot. All those things we will be seeing in detail in the upcoming videos. So, and GCP enables fine-grained control of cost of compute engine. So it enables fine-grained cost control. So this helps in reducing the cost when we are deploying our virtual machines for for batch processing, like as I told you earlier, for short period of time. So that non-promotable virtual machines, all those things will come into promotable virtual machines, all those things will come into picture for batch processing, all those things. So uh, so the next question is, so why do people choose compute engine? Everyone knows compute engine is an infrastructure as a service, and it is a basic building block of any cloud platforms. So with compute engine, you will have all the control over your infrastructure. So as I said earlier, right, we will be configuring the machine as well, like what is the disk size, what is the storage size, what is the memory or RAM size, what is the OS will be, all those things. We will be the one who will be configuring all those things. So we will have more control over it, and you can customize your operating system. So if you wanted to go with Linux, Debian, Windows, you can go with it, and you can run applications that rely on mix of operating systems as well. So like it is customizable, as I said earlier, it is customizable. And if there is any particular application like running in your on-premise, you have to just take and move it to Google Cloud Platform. Then virtual machine is the ideal use case for it. Like you can easily lift and shift your on-premise workload into GCP without reviewing your applications or making any big changes. So compute engine is the best option when other computing options don't support your applications or requirements. So if there is no Kubernetes involved, if there is no containerized, or if there is no any serverless, then basically this will be compute engine will be the ideal use case for most of the scenarios in real time. So this is where we will be using compute engine, and these are the some key features. So uh, I hope compute engine is clear when to use and what is the ideal use cases for choosing compute engine. The next is we will be talking about app engine. So app engine is offered by Google Cloud Platform as an platform as a service. So it is completely different from compute engine. Whatever we saw it, right, like it is completely different. It is basically as a developer we need to worry, or we need to focus only about the code. Rest everything, um, how the environment is infrastructure, how the deployment will happen, everything will be taken care by Google Cloud Platform. We have to just App Engine is a fully managed application platform by Google Cloud. Using App Engines means, like it means zero server management and zero configuration deployments. We don't need to worry about what is the server, where is the server, how the server is managed, how the server is created, all those things. And even the deployment also we don't need to worry about it. So if you are a developer, basically if you are a developer like Java, Python developer, you can focus on building applications. Like you can focus on building great applications, and rest everything, deployment part, all those things will be taken care by Google Cloud itself. So some of the key popular languages used in App Engine is Java, Node.js, Python, PHP, C Sharp, .NET, Ruby, and Go language. And the other key feature, important feature of App Engine is it easily integrates with other GCP services like stack driver monitoring, logging, cloud logging, debugging, error reporting, all those things. It can easily integrate with those things. And Stackdriver integrates with tools such as Cloud SDK, Cloud Source Repositories, IntelliJ Visual Studio Code, and PowerShell as well. So it easily integrates with GCP other services, and also it integrates with IntelliJ Visual Studio Code, all those things. So in App Engine we can in App Engine also supports version control and traffic splitting as well. So when you are deploying your application, and it like the traffic is completely into the first version of it, like then you are deploying the second version and you wanted to test whether that version is working fine or not. So you can use this topic called traffic splitting, and you can split 80% of traffic to the first version and 20% of traffic to the second version according to your business requirement. Like it will be 90 10, 80 20, 70 30, whatever it is. So it is a new, And App Engine is a good choice if you simply want to focus on writing code. You don't want to worry about building the highly reliable and scalable infrastructure that will run on. So when you use App Engine, the ideal, like, you have to worry about only the code, like the code which is written in Python, Java, Node.js, Go, all those things. You have to worry only about the code. So what are the ideal use cases for App Engine? So App Engine includes websites, to build a website, to build mobile apps and gaming backends as well. And there is another one more important concept all called RESTful APIs. So RESTful APIs is nothing but it is a way how web browser interacts with the web server. So to do that, we will be using this API, application programming interface, or easy for developers to work with and extend an App Engine makes them easy to operate. So when you wanted to communicate from web browser to web server, we will be using this API. So API is also, with the App Engine you will be able to easily build APIs as well. For that we will be using App Engine as well. So I hope App Engine is very clear when to use and what is the ideal use cases of App Engine. The next thing is we will be seeing Kubernetes engine. So Kubernetes is again an open source. It is used for orchestration system of applications in containers. So it automates deployment, scaling, load balancing, logging, and monitoring, and other management features. So Kubernetes is an open source. Uh, it is mainly used for orchestration, or it is mainly used for orchestration as well. And Google Kubernetes engine extends Kubernetes management on GCP by adding features and integrating with other GCP services automatically. It also integrates with other GCP services as well. So like it integrates with cloud build, container registry, stack driver monitoring, stack driver logging, and it even extend so it integrates with these things. Cloud build, container, when you after our application is up and running, you can use cloud build to deploy it, all those things. And GKE supports cluster scaling. So you don't need to worry about, like, you don't need to do any customizable configurations, all those things. By default GKE will do all those things. It supports cluster scaling, persistent disk, automated updates to the latest version of Kubernetes, and auto repair of unhealthy nodes. If there is any nodes which is present inside Kubernetes engine, it's not working properly, so Kubernetes itself will do the healthy check, and it will do the health check, and if that node is not performing well, it will drain itself, and it will create another node automatically. That is taken care by Kubernetes engine itself. By like it is taken care by Kubernetes engine itself. So the key features are, it is fully managed Kubernetes platform. So supports cluster scaling, person automated updates on auto node repairs, and it integrates with other Google Cloud services. So other Google Cloud services are this, and it even supports hybrid computing and multi-cloud computing as well. Hybrid computing involves cloud and on-premises Kubernetes platform, and multi-cloud computing, it involves multi different clouds like Google Cloud, Azure, AWS, or even with on-premise as well. So existing workloads running with an on-premise cluster can be moved easily to GCP. So when your existing workload is working is in Kubernetes in on-premises, the ideal choice will be moving it into Kubernetes, and there is no vendor lock-in. And since it is an open source, since this is an open source, it easily, there is no vendor lock-in for it. GK is very suited for containerized application, cloud native distributed system, and hybrid applications. So these are the ideal use cases where we'll be using Google Kubernetes engine. So yeah, in next video we'll be seeing cloud run and cloud function. So I suppose I believe that you learned something from this new videos. I hope when to use Kubernetes engine, what is the ideal use case, similarly for App Engine as well as Compute Engine. If you have any questions, doubts, or any concerns, please post that in the comment section. I'll take a look at it and reply as soon as possible. Please do like, comment, share, and subscribe to Cloud and AI Analytics. I'll meet you in the next video with the two other topics. Until then, it's bye from Vignesh, and happy learning.